Thank you very much for this invitation. Good morning. I am Ingmar Bruder. I'm a physicist by training, or also a professional layman, because we physicists know to do everything, but nothing really. I studied physics in Germany. In Stanford, I wrote my doctoral thesis, and it's never been my plan in my life to found my own company. Now, how did all this happen? This is my story and the story of and the history of my company I would like to talk about over the next 30 minutes. 2009, that's when it started, a new and novel way to measure distances. It has never been my plan to found a new company, and once I graduated, once I had written my doctoral thesis, it became very clear that I would like to join a major German company. We are not as bad, say, as the Japanese, but we are very conservative in Germany. It's different from those in the United States saying, after graduation, I want to find a company right away. I joined BASF, and I was supposed to work with photovoltaics. Now, one or the other of you might know solar cells. They are made of silicon, sand, the blue things which you find on roofs everywhere. And in 2006, when I started with BASF, they've been quite expensive. There was the rush of China, not yet in existence, and BASF is very good when it comes to paints and colors. And the idea was to develop a color or a paint which everyone can use to paint his or her house, and then attach 2 electrodes, and this means they can generate power at the end of the day. And I was part of this research project and was allowed to work with that. So what do you do typically? And this is the only technical chart I'm going to show you, but nevertheless I would like to explain it. I'm sure that there are some engineers among the audience, so you first characterize these things. Have we got a pointer, please? All right, have a look at the top chart. On the left side, you see the light source. I brought one. This is a flashlight. So here it has a lens and a solar cell. So this is an organic solar cell. And typically these things are being characterized. You've got a defined light source, how many photons are coming out, and then you beam this onto the solar cell. What you see here, up here, if you've got a silicon solar cell, if you move it and there's a lens in front of it, the spot reaching the solar cell will have different sizes, but there will always be the same quantity of photons hitting on the solar cell. Now, solar cells will, convert these photons into power, and there's always the same quantity. This means the power you measure is always the same. Well, so far, so unspectacular. Now, if you use an organic solar cell, then something very strange happens. And you see, depending on the distance, you do not measure the same quantity of power, but you will have a kind of curve. This means each and every distance which you have between the solar cell and the light source corresponds to one specific amount of power. This is a mini effect, but as a physicist, you're always unnerved if things are not like they are supposed to be. So I started to change BNC cables, buying measuring apparatuses, but this effect didn't disappear. So it became clear to me that this is a physical phenomenon which you've discovered, meaning you can measure distances. Every spot or dot corresponds to a distance to the solar cell. And you might say, well, what's so spectacular about it? Well, there are several possibilities to measure distances today. Think of whales, think of bats. They use ultrasound, runtime on transmission time processes. We call it radar, and, there's light and other possibilities. And this is what we do. We've got 2 eyes, and, they've got this displacement, you might say. And because of this displacement, our brain is in a position to detect distances. 50% of the cerebrum capacity is being used to do this. So it really takes a lot of power, brain power. Others call it stereo camera. You might have a car with a star in front, and they use a lot of these things in order to detect any distances. So what I discovered at the time is the first monocular technology in order to detect depth information. So nature's not doing that, but I can use it in order to detect any distances. I thought, this is fascinating. I want to turn it into a product. And actually, this was the first time that something must happen now. I cannot simply do my research work. The problem was I'm working for a company you know, transporting chemicals in some kind of tank wagons, and they are not, you know, doing any high-tech electronics. But, you know, I'm a DIY guy. And I want to use this chart. It's very compressed, actually. What has happened from the discovery to finding the company? In 2009, it became very clear to me that there is something. Well, there's a physical effect, but you can't buy anything for that. You have to show an application. And at the end of the day, you have to come up with an application, which, in an ideal case, at the very end of the day, you will also earn some money. So at home, for many years, I was working on that at home in the company, built my own prototype, and the BASF had a once-a-year event, and unfortunately this event is no longer organized. You know, this means the board of management is meeting and all the research elite is meeting there, and they discussed what's new in the group. And I had a head of division, and he was thrilled by my idea, and he gave me an 8 o'clock prime time presentation opportunity. He organized this, and I said what I'm doing, and I thought, okay, I'm very proud. Now I will be allowed to continue, will earn some money, I will get some money, that is. Well, the result was a bit sobering, because 2 days later I received a call saying, well, you are being paid to do solar cell research. What are you doing? Please stop this right away. Well, you know, it was like punching a hole in the wall. I made a very important experience, you know. You might always say a prophet has no honor in his own country. So you know that this is a chemical company, very successful, very old, but, you know, high-tech electronics, they haven't got any experience in this respect, and I need external feedback, otherwise I will not be able to continue. So it's always good if you've got an external perspective saying this is good or this is great. So what did I do? I had the first prototype, functioning prototype. I got in touch with electronics companies, Sony and others. Among others, also a company in the United States having an apple in their logo, and they wanted to buy some patents. And it was the first time when BAS people started thinking, well, maybe there is something to it. And after some years, having made the discovery, I was allowed to do some part-time research work and work on my idea professionally. And BASF set up a group, you know, dealing with 3D electronics. So this is similar, Würth dealing with fertilizers, you know. This is absolutely remarkable, I should say. So very quickly we collected lots of resources, and we had massive conflicts actually in the company. And here I slowly came up to the point where I said it's no longer possible. I invest a lot of energy in stakeholder management, and in this way survive in this research environment, which has got a different objective compared to mine. The BASF Board of Management also got wind of the situation, what we are doing. That is, in 2014, I was invited to give a presentation to Tier 1 and 2, or echelons of the company. And I decided that I'm going to discontinue my career at BASF. And I announced this. And then something happened which I didn't expect at all. That is, Mr. Bock, CEO at the time, he said, well, how much do you need in order to found a company? Well, I said 50 million euros and have some peace and quiet. And he said, deal. And this was something I've never ever expected. Now, in 2015, I founded trinamiX. The staff I had, we were 16, and we started on our route. And I said, you know, to work for a startup means you go to work every morning without any likelihood of future or success. We in Germany, we love statistics. 100 startups, 10 will generate 1 cent of revenue. All the others develop things nobody needs, and of those, only one, will be successful in the marketplace. But nevertheless, there's magic. Having one's own ideas being converted into products, you know, this tempts many generations of such researchers to go for this. And I'm really proud, and I really find it remarkable that BASF entered into this venture. And I should say trinamiX is among the last 2 of this large group. BASF has got a significant 3-digit million amount invested in my company. Well, here the German title says branch, but this is not correct. BASF, the 100% owner of our company, so we have a wholly owned subsidiaries, and I report to the board of management. But we are an independent company which has got nothing to do with the core business of BASF. We were founded in Ludwigshafen in 2015. This is where our headquarters are. But I should say that we've also become active in relevant markets, Northern America, Taiwan, South Korea, and in particular China, particularly in Shenzhen. You know, we are active there because many of our suppliers are working there. trinamiX is about brain and IP. Brain, well, I should say 170 members of staff are active for us all over the world, and IP is the foundation of this company. We sell our products to safety or security relevant industry, and therefore we were ISO certified, and this means this is a big step for a startup to develop into this level of professionalism, you know, working according to specific standards. Now, in the next part of my presentation, I would like to elaborate on this because that was the title. You know, it's all about a molecule to a smartphone, and where did this idea come from and how was it implemented? First, I believe, and it is very important for every one of us, to have an idea. And this means for a startup, it's very important to go to the office because you earn some money. I think that's a poor idea. You should always have a purpose driving you. And it is our vision to become active in an increasingly complex world, helping people using our technology to take decisions and make their lives more secure, more reliable. And we do so offering two products which are based on the idea which we had at the time. And I hope I can explain it in very clear terms. Usually startups should focus on one thing only, and this, you know, goes beyond or breaks up what I've just said. You know, on the one hand, because we offer two products, we deal with mobile spectroscopy, and the other one is biometric facial authentication or recognition, and we sell it to several markets: plastics recovery, animal feed, and consumer business. Well, pigs and smartphones, what they've got together in common, this is something which I'm going to talk about in a minute. All right. First, about our facial recognition, biometric facial recognition system. We have defined a new standard for facial identification. This is of importance in the consumer electronics business. During the pandemic, I'm sure many of you have started using their own smartphones to pay things because it's wonderful. You've got credit cards which you can store on that. In Asia, they skip this point. They use their smartphones anyway. And it is all about, you know, making the data on a smartphone very, say, secure and reliable. Though it doesn't really work very well. These are figures from 2019. Credit card companies sustained losses to the tune of $28.7 billion. So this means there are some people who get access to smartphones, hack these smartphones. So I should say that there's a high demand to make things more safe, secure. And the second issue in the consumer electronics business is design. Design will beat everything. Smartphones must look beautiful. And a company having their apples on the devices, you know, perfected this. Others try to copy this. But our USP, and this is what you can see on the right side of this chart, is we want to use our technology offering maximum design freedoms to the company by using our facial identification system. It can be built or set up behind the display, and at the same time we offer the highest level of security for mobile payment systems. What does it mean? One or the other of you might certainly have a smartphone of this US manufacturer. They're the world market leader when it comes to facial recognition security. But they can't put it behind their display. There's a big edge, and the yellow press always calls this the screen notch. I think that's a very strange term, but nevertheless. You see, in the Google universe, there's nothing like that. You have to use the fingerprint method, or you use a pin. And the trend is that the displays are whole, so no holes, nothing in there. And you know, you can't get these things together somehow. And you know, this is what I wrote on this chart here. There is a so-called certification for secure facial recognition systems. FIDO Alliance, you know, Huawei, Samsung, Apple, others are members of that alliance, and they define certain standards, how facial recognition works. There are 3 standards, A, B, and C. A means you can have a photo, you can distinguish it, that is 2D. This is standard today. Now, me or Mr. Bruder or somebody else, but you can fake this easily, because if you hold a photo behind it, then it is still me. So and then there is FIDO level B. And here Apple is the market leader in this respect. This means we can identify people very clearly using 3D topography. So if you have a picture in front of it, then this is not enough. And you know, one or the other might have this US manufacturer smartphone. You have to move your face, and then it will face your facial features. This means it's quite secure, because you will not be able to do that just using a photo. But today we've got 3D printers, and this means you can print silicon, and you have real live faces. And I always scare my children. It's really fun, I should say. Well, you know, my little daughter is a bit too, you know, for her it's very strange if her daddy, you know, comes into the room twice. And I must say my wife doesn't find it very funny, but nevertheless. And the current market leader can be deceived in this respect as well. Therefore, no company has had this level 3 standard. This means you've got real-life silicon masks. They can be distinguished. Now, what our technology does, that in addition to 2D and 3D, we are able to distinguish materials. Is it silicon? Is it live skin? Or is it dead skin? So in August, we were the first company in the world to get this standard for facial recognition. And the second is, this is for the Android universe. Google also has got specific biometric certifications, which we got. The Chinese are handling things in a different way. Maybe Alipay is a name you know. They are 3 times larger as PayPal, and this is the largest payment service provider. And our Asian and Chinese customers, well, we are working with them in order to certify our system for the Alipay systems. Now, I would like to give you an idea. In 2018, the first functioning prototypes were available. And of course, we cooperated with partners and customers in order to come up with a certification that the value chains are being built up, etc., etc. And we came up with a generic product which is produced by OEMs, and it is being certified. And we are cooperating with 3 of these companies and, you know, convert it into a real-time product. But over the next few years, you will be able to buy these trinamiX products for, well, the amount or the revenue will be millions or billions even. All right, so this is the first product. Well, you can do something else with these products, but this is not what I noted here. You know, this is automotive industry. If you just think about it, you know, you want to enter a car, you open the door, and of course you want to be on the safe side without a special key. And of course, you know that probably if you've got a rental car company, the second passenger in the car, is it really the one who booked the car? So in-car payment system, this is also very important for the automotive industry. And then access control, also very important, but there won't be any products next year. But this is very manifold, very diverse, how you can use the technology. But as I said, we focus on smartphones. The second area where we are doing this, mobile spectroscopy, and now I would like to say, get away from the automotive industry and just, you know, see. You may know Star Trek. You have got this tricorder, you know, they're walking around, you know, scanning things, and then they say what's in there. But you know, you can detect real molecules, what's a chemical, what's plastics, what's in your body. Spectroscopy, IR spectroscopy, this is a technology 60 years old, usually big boxes, you know, shoe boxes, you might say, and organic materials put into them, and then light is beamed onto them, and if this is skin or other materials, then the light is, you know, reflected. And this, you know, has a specific fingerprint. This means you can say what it is. Is it carbon? Is it oxygen? Whatever. So these are all organic molecules, and you can use it to identify, say, materials. These devices cost a lot of money. You need trained physicists, laboratory technicians, ones who process all this information. So somebody coming up with a spectroscopy example, telling you what to do with that. And with our sensors, you can do exactly that. And what we've done is a first-time effect. We want to make available spectroscopy for everyone. We've got these large devices, and we made them very small. In Ludwigshafen, we've got the largest production for infrared sensors worldwide. So we build, or they build, these sensors, and of course we do build these spectrometers, but not really. The data are analyzed in the cloud. Machine learning algorithms are analyzing this, and the results are then sent to a smartphone and give the user feedback what they can do. What's the use of it? We are working for plastics, beauty, farm to fork. There are an unending number of applications. Let me give you a specific example. Just imagine, talking about plastics. That's a big issue, sorting plastics. Now, what do? You go to these waste collection points, and then you place everything in a heap, and then you burn everything in one go. Why? Because you can't sort it, because it costs too much money. You can't put it into a large spectrometers. Just imagine you've got this device like this one, and every unskilled worker can use it. Very easy. So you've got this plastic chair, say. So push a button. Then it will measure the spectrum of this plastics. It will be sent to the cloud, will analyze it, and then on your smartphone you see the result. This ABS or any other kind of plastics. There are more than 30 plastics types which can be analyzed. So this person can then take the chair and, sort it. And there are gargantuan amounts of money which come free. To sort plastics, it's much more cost-effective than burning it. So what was missing was a device which will help you to distinguish the different types of plastics. Another issue is, and this, of course, is a big issue, actually, and I'm very happy to say that our investor is not only an investor, is also a customer of ours, because BASF is a world market leader in terms of animal feed. The day before yesterday, I learned that there is a pig belt in northern Germany. There are many pigs, many, farmers raising these pigs, and spectroscopy is a big issue there. I had to forget the idea that animals on a green meadow, this doesn't happen. It's an industry. And what's special about it is that you give as much feed and energy to the animals that they can convert it into muscle mass and do not excrete it. So we've got two parts to their feed. Hay, this is a natural product. On the one hand, and of course, it's going up and down when it comes to protein, for instance. And then they add concentrated feed. And of course, they want to do it with a good mix. This means so much concentrated feed, which is necessary, but not more, because it's expensive. And so for decades, they've used spectroscopy, so they do 1 or twice a year kind of analysis. This is then sent to an analysis center. They give feedback, and then, of course, the farmers are going to use this or that much say, concentrated feed. We enable the farmers to do that every day, and this will optimize the feed for their pigs. And this means they will save money. They need not buy as much, say, concentrated feed, and they will always be right in the amount of concentrated feed they include. So after negotiations with BASF, we said, or we negotiated that we are going to market, or that they are going to market our product worldwide. So this was the mobile solution here. But I was talking about smartphones. We didn't want to have it in a smartphone. We want to build it in there. Then I've got 2 more charts, and then I'm going to show you the current situation and when you will be able to buy it. Okay, have a look at the top part of this chart. You always need an application. Spectroscopy is always very nice, but what about it? What's the benefit? And, this is what I've done in Asia. The Asians, they like cosmetics more, obviously, than we do. They're a huge Asian cosmetics company. Shiseido is one of them. They use our technology. These devices then analyze the skin, fat content, pigment content, many skin markers, and then they offer bespoke creams to their customers. They use our handheld device. It's a bit larger than this one here, this trigger. And another application, and I'm very proud of that personally, we are doing that with NGOs in Africa. You see, we use fingernails in order to measure whether they've got diabetes. Now, in the first world, children go to a doctor and then blood is taken, but you can use spectroscopy in order to measure this using or analyzing fingernails. And this means even in remote areas, you can find out what disease people have. So the point is to bring this technology into a smartphone. So we have the first functioning prototypes in place, everything very, very small, I should say. And the roadmap here is, the application is available already. The technology has been miniaturized significantly so, and we've gained a lot of experience over the years, facial authentication and, consumer electronic smartphones. This is what we've learned while dealing with that. And our ecosystem partners, cosmetics and pharmaceutical companies, the smartphone manufacturers, the smartphone the tiers, we want to introduce new hardware. And we will be able to offer mobile smartphones in 2024. And then the holy grail is to measure blood sugar, everyone to be able to do so. Well, this is not possible today, but this is our vision. This is what we want to reach. Not to build some kind of tool, but to build some kind but to build some kind of tool which will help people to improve their lives. Well, having said that, that was trinamiX. Thank you very much for your attention.